In this video, we'll make an attempt at explaining or at least describing what the likelihood is when we're talking about maximum likelihood ratios and things like that. There's a likelihood statistic is one that's used in fitting the logistic regression. Let's start off and look at in our, we did our logistic regression of using pupil size to predict either good or poor fitting spherical lenses. And we see here that there is this statistic under model summary called -2 log likelihood. And so the question is, what the heck is that? And in the text we were looking at, the likelihood ratio is this rather ominous looking formula. And what that means is you predict each individual I who was a person that had poor control, who was in the poor control group, and you multiply all the probability, so you calculate the probability for each of those. And we did that in our logistic regression. Under save, we saved the probabilities. And that gave us these probabilities here. And so I have copied those probabilities into the 68 into Excel. And so this column 68, there it is, 68, 86, 43, 68, 86, 43. That column, all those numbers are copied here. And then we said we multiplied all the P's. Now the first group of people here are all those with that are of one lens type. And so there were, let's take a look here. For the, I believe, left eyes, these are the probabilities. And I also, when I was calculating these probabilities, I looked at the predicted value. When I calculate the predicted values and when I put them into this line, I actually had to create a new variable in SPSS. So that's the 68. So when this subject is lens type 0, and so when the lens type is 0, we had to compute a variable 1 minus PRE3, 1 minus predicted value. That's because we have the predicted value for when it's P, which is P is when it's a poor control, and 1 minus P when it's a good control. So for a big block of these, we had to make them 1 minus P. So hope that's sort of clear. We have two types of probabilities. When it's a poor control, that's what the model is predicting, the SPSS model is predicting. That's P. And when it's a good control lens, the value we want to enter into the equation is 1 minus P. And so we have done that, and we've loaded them in here. And notice this first one is just, now we're going to work out the formula. The formula being multiply all the p's together, multiply all the 1 minus p's together. So it's a string of 96 multiplications. P, the first p times the next p times the next p, and then you get to the other kind of p's, and it's 1 minus times 1 minus p. It's all one string of multiplications. The way we do that is we multiply this number times this number. So we go to the current number times the number before, and we just keep doing that all the way down. So this column is our running total, and we get down here to a really, really small number, 2.17 e to the minus 22. That's that 2 with 21 zeros in front of it. It's a really tiny number. But remember, and that's the likelihood. Now, they actually made the likelihood a little bit easier to read by doing minus 2 times the log likelihood and times the log likelihood. And so that's this number. It's minus 2 times the natural log of 2.17. So that's a value that's 99.76. If we look on here, we can see we're pretty close to that. This is the left eye. This is the right eye. When you get down to numbers that have that many significant digits, it gets hard to get little tiny rounding errors. So we're at 99.77 and 83.191. Pretty close. Pretty close. Now, that's for the model. Now, when we first start, how does the model fit by itself? Well, let's say the probability was a coin flip, and each time you were 0.5. You had a 0.5 probability of being in either case. And so that would be 0.5 times 0.5 times 0.5 and so forth, all the way down to this really little number. The log minus 2 log likelihood of that is 133. Now we can't really use 0.5 because that's not the baseline. Actually, the baseline for this study was there are 40 over 46 is the probability that we're interested in. 40, let's see, if we come up here, yeah, there's 40 poor controls over a total of 96. So the proportion is that. So rather than 0.5 times 0.5, and we're looking at what is it if you didn't have pupil size. This is the intercept model. We only have, we don't have pupil size as information. It's like a regression equation. It's like a mean. We want to see if our pupil size can improve on that. Well, what's it going to improve on? It's going to improve on just the probability of being in the poor group, which is 41.667. And that has a log likelihood of 130 for the left eye. So it's 130 if pupil size isn't there, and the log likelihood is 99 if it is. And if we subtract 99 from 130, this is a chi-square. Now if we look over here in our model chi-square, we can see the omnibus test of model coefficients, and that's a chi-square of 30.62. And we're pretty close to that one too. So that's a chi-square for that eye, 45.6 for the other, for the right eye. So that's our overall test of the model fit in terms of a chi-square. And the null hypothesis is that there was no effect, which is 130, and we got 99. And is 99 significantly different from that? Well, it's a chi-square of 30 with 1 degree of freedom, and that's significant at p pretty small. so we reject the null hypothesis that of no effect of pupil size. And that's how you do, that's what maximum likelihood is all about.